Today we'll look at transforming circular functions. It works similarly to all the other functions that we've worked with. The trig functions have some identities that can be applied, but we'll worry about them later. So we're starting with y equals sine of x, and this is the first set of transformations that we'll do, dilated by a factor of 2 from the x-axis. Dilated by a factor of 3 from the y-axis. Translated 5 units in the positive direction of the y-axis. What was it? Plus 5. Yep. And then 2 units in the negative direction of the x-axis. So 3x. Take 2. Okay. X dash and y dash. So x dash is 3x take 2. Y dash is 2y plus 5. Add 2, divide by 3. Take 5, divide by 2. Ugh, what did I write down next then? Y dash take 5 over 2 equals y. Alright, new function time, so sub y and sub x. So y dash take 5 on 2 equals the sine of x dash plus 2 on 3, multiply by 2, add 5, y equals 2 sine x plus 2 on 3 plus 5. Alright, so there's our new function after these transformations. We can also use function notation for this, so let f of x equal the sine of x. Right, let's do the dilations both at the same time. So we'll create a new function g of x, which is 2 from the x-axis, 2 f of 3 from the y is x on 3. So that's those two taken care of. Now let's do the positive direction of the y-axis. So g h of x equals 2 f of, and we're going to do the plus 5 units in the positive direction, so plus 5, and 2 units in the negative direction means I need to drop x plus 2 where I see x. That's going to be x plus 2 on 3. Alright, let's make our function h of x is 2 sine of x plus 2 on 3 plus 5, which is what we got here. Okay, next one. So we'll start with a mapping and then we'll go to function notation. Dilation by a factor of 3 from the x-axis, x comma y. So 3 from the x-axis changes to y. Translated pi in the negative direction of the x-axis. And dilated by a factor of a half from the y-axis, that changes the x value. So it's going to be half x take pi, comma 3y. X dash, y dash. X dash equals half x take pi, y dash equals 3y. So y dash on 3 equals y, and multiply by 2 and add pi. So 2x dash plus pi equals x. Right, time to make the new function. So we've got y dash on 3 equals the sine of 2x dash plus pi times by 3. Y equals 3 sine of 2x plus pi. Alright, let's go functions. So let f of x equal the sine of x. Let's do dilation by a factor of 3, and we'll do the translation as well. So let's go g of x equals, so 3 from the x-axis is 3, not sine, 3 lots of f of, so translated pi units in the negative direction is going to be, so pi units in the negative direction means we drop in x plus 2, x plus pi. Right, dilated by a factor of half from the y-axis, so that means wherever we see an x we replace it with 2x. So GH of x equals 3f of 2x plus pi. Therefore, h of x equals 3 sine 2x plus pi, which is what I got here. Alright, so this one here, state a possible sequence of transformations that are applied to this to give this. So I hope this is almost intuitive, that you see this and you go, that's a dilation. So I'm going to write that. Dilation factor 2 from x. And this one here, hopefully we can see that is a dilation factor 1/3 from y. If you wanted to be 100% sure, we'll go from y equals sine x to y equals 2 sine 3x. So y dash, okay, so we've got this one as y dash on 2 sine 3x dash. Okay, pair them up. X equals 3x dash. Alright, so to read the transformations, that's where x dash goes and that's where y dash goes. So we need to make x dash the subject. And we need to make y dash the subject, 2y equals y dash. Right, and here we can see from the mapping that this means 1/3 from the y-axis and 2 from the x-axis, which is what we wrote down here. So that's how I would do it, is I'd try to use intuition. But if you're unsure or there's some more complicated things going on, usually when there's translations, horizontal translations, I'll often run some mapping on it just to make sure I get the order correct. Okay, so speaking of, this is one where I'd be concerned about the order. So let's just go f of x equals -3 sine 2x plus pi on 8 plus 1. So now that we've got it with the one single x, what we can do is run Dr. T on this and state the transformations in the form dilations, reflections, and then translations. So what we've got is dilation, so this is a dilation factor 3 from x. It's reflected in the x-axis. This 2 represents a dilation factor half from the y-axis. And this is a translation, pi on 8 to the, what are we doing? Pi on 8 to the left, and a translation 1 unit up. So these will be a possible set of transformations. Let's run some mapping now and see what mapping tells us. So we're going from y equals the sine of x to y equals -3 sine 2x plus pi on 8 plus 1. Right, so I'm going to subtract 1 and divide by -3. Okay, also to make sure I don't get confused with my y's and my y dashes, the image gets dashed. Okay, so pair up the y's. Y equals y dash, take 1 over -3. X equals all of this, 2 x dash plus pi on 8. Alright, now we need to make x dash and y dash the subject, so that's going to be -3y plus 1 equals y dash. This one here will be x on 2, take away pi on 8 equals x dash. And now we can just state the transformation. So this one here is a dilation half from the y-axis. So there's that one there. And a translation pi on 8 to the left. That's that one there. This one here is a reflection in the x-axis. That's that one there. It's a dilation factor 3 from the x-axis. That's that one there. And one up is that one there. So I can get it via the mapping, or I can use Dr. T, so long as we go to one single x. Now also note that if you went from this function to this form of the function, what you'll get is a different set of transformations that will be equally appropriate. So that's what you've got to be really careful about with transformations, is you could be right. You just haven't got the same set of transformations that I've got. Okay, so last few problems. State a possible sequence of transformations that may have, or that have been applied to this to become this. Now this gets harder, and it's harder to use intuition to go from a transformed basic to another transformed basic. And really the only way I do these ones is by using mapping. So we're going to go y plus 5 over 4 equals the sine of 2x. So that's what we're starting with. So we're going from this to this one here, which is y plus 2 equals the sine of x. Alright, so let's pair them up. Y plus 5 on 4 equals y dash plus 2. And 2x equals x dash. Alright, so for this one here, what we'll do is we shall, what are we doing? We need to get y dash by itself. So we're going to go y over 4 plus 5 over 4 take away 2 equals y dash. Fix this up in a sec. X dash is already the subject there, so we don't need to worry about that one. Okay, so this one here, let's just clean up shop here a bit. So it's y over 4 plus 5 on 4 take away 8 on 4 equals y dash. Okay, let's do the subtraction. We've got y on 4 take away 3 on 4 equals y dash. Okay, so a possible set of transformations will be to dilate by a factor of a quarter and translate 3 on 4 down. We could then do this one here, which is a dilation factor 2 from the y-axis. We could clean this up a little bit and say that this is y take 3 on 4 equals y dash. And in that case, what we would do is lower it by 3 units and then dilate by a factor of a quarter. So it doesn't really matter what you do algebraically with it, as long as the algebra is correct, like you've written a true statement, then you can state the transformations. So let's start with this, and we'll go, it is a dilation factor 2 from the y-axis, and this one here is a translation 3 units down, and it's also a dilation quarter from x-axis. Now this translation 3 units down might seem a little bit counterintuitive to these functions, because if you actually have a look at this function, it is, and actually I might just graph this. Let's ad lib a little bit. This is usually when it goes wrong for me. Okay, so let's graph the first one, which is y, or f of x equals 4 sine 2x plus, take away 5. And this is, we need to go to sine x take 2. G of x equals sine of x take 2. Right, so what you can sort of see is it's at -5 and we want it to end up at -2. And so you might think logically that the translation should be to go up by 3 units. But that's sometimes the case with transformations, is when you get them, they don't seem right. So this one suggests a dilation factor 2 from the y-axis. Well, we're not going to worry about that. We're interested in these two here. So if I translate this function here, which is currently at -5, so I'm just going to draw a mean line in, y equals -5. If I translate this line down 3 units, I'll get to -8. If I dilate them by a factor of a quarter of -8 is -2, and it's going to shift up to that point there. So I suspect my transformation is right, even though I feel like it's a bit counterintuitive. Anyway, let's run the transformations and see. So dilation factor 2 from the y-axis will mean that I do f of x on 2. Alrighty, now let's do, so that's the dilation, translation 3 units down, so that'll be take 3, and then dilation a quarter from the x-axis, so we'll go a quarter times all of this, and there it goes. All right, it's shifted to that one there. So what it did was moved this function. Where did it move it to? It created this new function here. Ooh, just so happens it's exactly the same as the one I was trying to turn it into, so that's perfect. All right, so my transformations work. So again, what you can see is a great way to test your set of transformations against the ones or test yours against, say, the textbooks, and just see whether they match up, whether they produce the same function. These last two examples are late additions, and they're pretty tough. So what we're going to do in example 4 is go from y equals sine of x to y equals cosine of x. How, I hear you ask? Well, what we need to do is we actually need to turn this cosine graph into a sine graph. Now, how do I do that? Well, what we need to note is that sine of x looks like this. So we're at pi on 2, pi, 3 pi on 2, and 2 pi over here. So it'll go bang, 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 bang. Like that. Right, now, if I want to turn this cosine graph into a sine version of it, all I would do is move the standard sine graph pi on 2 to the left, okay? And what's going to happen is it'll turn it into a cosine graph. So I can actually rewrite this cosine graph as sine of x, and to move to the left, I'm going to go plus pi on 2. Now let's just confirm that with GeoGebra. So pull that up, and here it comes. So I'm going to graph y equals cosine x. But what if I didn't want to use cosine and I wanted to use only sine? That's fine. Y equals the sine of x. And which way was I moving it? Plus pi on 2. Come on. There we go. So it's basically turned this, so I can use, instead of using cosine of x, I can use sine of x plus pi on 2. All right, and so it's pretty much done for us then. Okay, so all we would do is, how would you translate that into a cosine graph? You would translate pi on 2 to the left. All right, this last one is tricky. So this one, what we want to do is we want to transform 2 sine x to this graph here, which is cosine of x on 2. Now again, what we want to do is we want to turn this into the sine equivalent of this graph. So we want to get the same graph but use sine, not cosine. All right, so let's just think about the period here. So the period of this one is going to be 2 pi over half, which is 4 pi. Scale is going to be 4 pi over 4, which is pi. Right, now with the other question, what we did was we translated, or we made this cosine graph using plus pi on 2. This time all we'll do is use the pi. All right, so we're going to rewrite this as y equals sine of, now where we see x, we're going to replace that with x plus pi, and then we've got our dilation. All right, so this graph here and this graph here should be exactly the same graph. All right, so let's just try it out. Okay, so I'll get rid of u and u. Graph my original, which is y equals cosine of x on 2 and y equals sine of x plus pi over 2. Bang, same function. All right, so I don't need to write it as a cosine, all I need to do is write it as a sine. Now once I've got it written like this, then it's a simple case of using your favorite technique. If you can do it by recognition or equation, then feel free to. So I'm not really comfortable once there's a transformation on the original and where I'm heading to. I will generally map these out. Now I'll just see if I can get it out by intuition. So this 2, what will happen here is that's going to be a dilation factor. So this one will have to be dilated by a factor of a half from the x-axis, and then it's going to be dilated by a factor of a half from the y-axis and translated pi on 2 to the left. Let's just see if that works out. So we're going to go, this is dashed and this is dashed. So y over 2 equals sine of x. Okay, pair those. Y dash equals y dash equals y on 2. Right, so that's confirmed. My dilation half from the x-axis. All right, now this one here, we're going from x to x dash plus pi all over 2 times by 2, which is 2x, equals, not equals, take away. All right, so this one here will be a dilation factor 2 from y and a translation pi to the right. So I did stuff up that by recognition, so all the more reason. I think I said half from y, which is silly. Okay, so all the more reason to use mapping on this one. So we'll just write it out formally. So this is here, that's a dilation factor 2 from y, a translation pi left, and a dilation half from x. Right, and again, just don't forget that you could actually factor out the 2 and write this as x take pi on 2 equals x dash, and then your transformation will be half from 2 from no, it'll be translation pi on 2 to the right, and then 2 from the y-axis. So you'll get a different order to the transformations if you choose to make some more algebraic moves. Anyway, after all that, pretty long video for 3 questions. Good luck.